In parts 1 to 3 of this series we started off with the box, and we've also seen the big fat instruction books that come with it. There are many parts, probably thousands of them, and then we moved into building the model and we started with the carrier cab. Parts were built and tested, such as these outrigger beams and the complicated carrier chassis. The build continued until the carrier was able to run on its own wheels, and then the outrigger beams were added on, and there was more testing of the mechanisms. With the carrier assembled, work moved on to build other parts, including the crane cab, and here is the counterweight tray that goes on the back of the crane. Also prefabricated were the ballast weights, and there was a load box, and of course the various parts of the boom. Now in this part 4 it's time for the final assembly. The manual refers to a main boom rope installation. However, the manual is not at all clear what the rope is used for and how it runs. The boom is a 3-section telescope, and in assembling it we'll use our own system. Here we've used a very thin rope and tied it to the end of section 1, and then run it inside the boom so it runs back down over the first collar. With that done, we'll insert the first boom section into section number 2. It slides easily, and we've also added a small extra pin in to help the rope to run smoothly. So with that done, we can fully insert section 1 into section number 2. The point of doing this is that when section 2 gets extended, the rope is of a fixed length, so automatically it pushes out section number 1. Well, that's the theory anyway. The other end of the rope gets fed into section 3, and it gets tied on at the recommended tying point. We then feed in section 2 into section 3, and the reason we're using a very thin rope is because it has to run between the sliding surfaces, which is not great engineering, but we'll see if it works. Next we'll assemble the crane cab onto the crane body, and it pins into place on a couple of beams. It can then be rotated to and from the transport position, and next we place all of the roller bearings onto the slewing ring on the carrier. We then have to drop in the crane body, and we just have to hope that everything lines up and is working properly. You have to push the crane body down until it clips in, and of course all of the weight of the crane is on this part, so you have to make sure it's fixed properly. Next we test the crane's rotation. It works, but it's struggling a bit with the size of what's being moved. The next job is to mount the boom onto the crane carrier, and there are locking points for doing that. With the boom attached, we've temporarily supported it so we can insert the main boom ram. Once it's pinned into position, we can use the electric motor to lower it into the transport position. The loads on parts of the model are getting high. The next thing to do is to fully configure the crane by adding the Y-guy attachment. The real crane uses this to stiffen up the boom and increase the lifting capacity. Next we run the rope onto the winch drum, and the motor for that works well. With the rope on the drum we can add the hook at the front, and we'll also make a connection to the tying on point. So that's the crane assembled, but there is one more thing you can do, which is to add the stickers that come with the model. These include Mammut and Liebherr signs and number plates, but we're going to leave these off the model. The next test is, can the crane move fully loaded? And the answer is yes, it can. But again, the overall weight of the model is high, so both the motors and some of the gear mechanisms tend to struggle. The motorised folding out of the outrigger beams doesn't work so well, but the extending beams is a simple mechanism, so it works well enough. Lowering the pads is done by hand, but in a way it's more for show because the beams aren't really going to have much load carrying capacity. Next we'll fold out the cab into its operating position, and we can also raise the handrails on the top of the body. The next job to do is to add the counterweight tray at the back of the crane. There are beams sticking out which the tray has to pin into, and it's a little bit fiddly to get your hands in to fit the pins. You can also see that there's a fair bit of flexing in the system, and when it comes to adding the counterweight themselves, well, they're hollow, and as the manual recommends, you need to add some ballast into them. So here we're stuffing in some metal plates, and again the model creaks a little bit under the heavy loading. Now we're ready to raise the boom, and in reality the motor and mechanism are just not strong enough to lift the heavy boom from a flat position. So you need to give it a hand, and only when it's reached a steep angle does the motor work on its own. Next we've put a little bit of weight on the hook so the rope runs smoothly. And now it's time to test our string theory. So a motor drives up the second boom section, and when the rope gets tight, section 3 should start extending. And the good news is that it actually works very well. Of course the reel crane doesn't work like this, because on the reel crane a hydraulic ram pushes up each section in turn and then locks it. But some smaller telescopic cranes do have rope systems like this. It's actually quite satisfying to see it working. One thing that you can certainly say about this model is that it is huge, so let's do a dim check. End to end it's about 40 inches or 102 centimeters. Let's check the height with the boom fully extended, and it's just about 5 feet or 152 centimeters. One other way you can display the model is using the Y-guy attachment, and you raise these up by hand using the screwed pistons. Once they're up, they fold out sideways, and then you reinsert a plastic pin to lock them into position. Now there are no working winches modelled on the Y-guys, so you have to just use static ropes. And here you can see black rope used to the boom head, and white rope for the guys to the boom foot. Adding the Y-guy system adds a little bit of rigidity to the model. In conclusion, this is not a model for a beginner. It's a complex model and the instructions are not always straightforward. It impresses because of its huge size, but that's also its weakness because the motors and mechanisms struggle with the heavy weight. It's an interesting challenge to build a model like this, and size does matter.